Hello guys, so today I'll be solving date code problem number 35, which is combination sum. And what we are required to do here is we'll be given a candidates array 6 comma 7, and what we need to return a target. Say the target is given 7, so we know we can take 2 two times and 3 one times. So repetition is allowed, and we need to make sure that it reaches the target. So, and we have to form all such arrays which are possible. So only two are possible in this case, so we need to return that as a vector of vector. And the first thing that we need to come up with is a strategy. So for such problems, I think backtracking is the best way to move. But for backtracking, we need to make sure what is the time complexity that we can reach. As we can see, the constraints are like the candidate's length is less than 30. So 2 power 30 is maximum that will operations that can be performed. 2 power 30 is approximately 10 power 9, and I think 10 power 9 operations would be done in a second. So we can form a solution with 2 power n time complexity. So with that we can move forward with our answer. So what we are required to do here is we need to return a vector of int. So let's write a vector of int, and let's name it answer. This is the form. This is the final answer. Next, what we need is a temporary vector to store temporary array before backtracking. So we write this too, and the next thing that we do is we write a backtracking. We call backtracking. So what we need to give this things is an index which is 0. We'll start with the 0th index. We need to give it the answer. We need to give it temp. We need to give it candidates, and we need to give a target. Okay, so that seems okay, and we need to return the answer. So let's write the backtracking and the recursion function which will backtrack inside. So we need not return anything, so void of dk, and 0 is int index ind, and the next thing we give is vector of answer, vector of int of ampersand answer. Don't forget the ampersand sign, it's very important because we are passing by reference, so that the changes are accounted when we leave the function. And we also have to give vector int ampersand temp vector int. Let's move this thing a bit here, the left side, so you can see clearly. Ampersand candidates, and we also give it in target. Okay, that should do the thing right now. So in every recursion function, the first thing that we need to do is check for the base case. So we'll write a base case if index, sorry, int, that the name is int, is equal to what? Candidates dot size. If int is equal to candidates dot size, then this is the base case that we're writing. So what will we check? If target equal to, sorry, so what this is checking is, have we reached the target? And if the target is reached, the next thing we need to do is we just push back the temporary variable in the answer. So answer dot push back temp. Okay, and after that we need to return, and as it is void, we need not return anything. Now let's write a recursion function. So before entering into recursion, we need to make sure that the candidate's element at the index is less than the target, because if it exceeds the target, it doesn't satisfy solution at all. So we will just increase the computation. So we are trying to optimize the solution. So we'll search for if candidates of index is less than or equal to target. Only then we will go for the recursion. Okay. So first thing that we do is we push the element at the index into the temporary vector. So temp dot push back, and we push back what? Candidates of index. So that is what we are pushing, and semicolon. And the next thing that we need to do is we need to call a recursion function again. So pk is a recursion function. So what will we pass here? We'll pass again the index. Why we are passing index and not index plus 1? Because repetition is allowed, as we have discussed before. Sorry, that is int, which is index. And the next thing we pass is answer, comma temp, comma candidates, comma target. But here the thing is, we have already pushed the variable at the index into a temporary variable. So we reduce the target by target minus candidates of index. Okay. So we will complete this recursion. After this recursion, what we need to do is we need to backtrack. So while backtracking, we need to make sure that the variable that we have added in temp is popped. Temp dot pop back. And what will you pop? Like the last element which you have added. And after completion of this, what we need to do is we need to move towards the next index and again call the recursion function. So gs index plus 1 answer comma temp candidates. And what will we give? Target or target minus? Since we are assuming that we didn't add anything or the target will be modified, so what we put is target. So this completes our recursion function. And now let's try to run it. Okay, so there's an error. Oh, sorry. The name is bk for the function. Okay, so it is accepted. So let's try to submit and check whether a solution is correct. Oh, so we have successfully submitted the solution and our runtime is also good and memory usage also seems good. Okay, so that's it for now.